Good morning. Good morning, students. Today, study motion equation. The previous video explained graphical representation of a motion, and today explain motion equation by graphical methods. Need motion equations. When an object moves in a straight line, with a uniform acceleration, it is possible to relate the velocity, change in acceleration, and distance covered by a body in particular direction, that is also known as displacement. Within a time taken, and explained by the three equations. Obtains the three equations. That equation is V equal to U plus AT, S equal to UT plus AT over by 2 AT square, and third 2AS equal to V square minus U square. These equations are derived by graphical methods. As first, let us consider draw the graphs. Draw graph. Y-axis, x-axis. X dash, origin, y dash. On a x-axis, time, t, time on x-axis, and y-axis, that is velocity. When an object moves with some velocity, it means u is not equal to 0, and uniformly moves to A to B. This slope represents the uniform acceleration. With the help of this, it relates velocity, acceleration, and obtains the three equations. That equations are known as motion equation. Construction: draw perpendicular on x-axis that represents the D points, and from A, here draw perpendicular on a x-axis, BD perpendicular on x-axis, and A to C, it is also AC perpendicular on BD, and then obtains the value. This value is U, initial value, that is U, and this value, that is the V. B to D represents the V. C to D, that is parallel, and represents the U, and B to C, that is V minus U. This is written as AO equal to the CD equal to u. AO equal to CD, that is equal to u, and BD equal to V. BC equal to BD minus CD. BD minus CD. Here BD, that is the V, and CD, that is U, and BC equal to V minus U. BC equal to V minus U, and it is explains as slope AB. Slope AB is represents acceleration in triangle ABC. Slope AB, that is the A, equal to change in velocity. Change in velocity upon mean time taken. Here also OD equal to AC, that is equal to T. AC equal to T. And here change in velocity, that is the BC, and AC, here AC, BC upon AC, that is A equal to V minus U upon T, and V minus U equal to AT. V minus U equal to AT, and V equal to U plus AT. This relationship is known as velocity-time relationship. This relationship is called velocity-time relationship. And it is first motion equations. Second motion equations. These explained as repeat such graph. Let us consider draw graph between velocity and time. Now y-axis velocity, x-axis time. When a body moves with some velocity, u is not equal to 0 and uniformly accelerated, and the slope AB that represents the uniform acceleration. Construction: BD perpendicular on x-axis, AC perpendicular on BD, and the value of AO equal to CD U, BD equal to V, VC equal to BD minus CD, that is V minus U, and OD equal to AC, that is equal to the T. On the basis of this obtains the first equation, the first motion equation. This motion equation is known as a velocity time relationship. The second equation, in a previous video explains area under the graph in a velocity time graph that represents distance traveled by a body in a particular direction, and it is also called the displacement. It is equal to the displacement. So this area of this displacement equal to area of OABD. That is also equal to the area rectangle OACD plus area triangle ABC. Area of a rectangle, that is length into breadth. Area, that is length into breadth, that is equal to AO into OB plus area of a triangle area, that is 1/2 AC into BC, and that is also equal to US equal to U into T plus 1/2 into T into V minus U. And here in a first equation, V minus U equal to AT. Therefore, S equal to UT plus half AT square. Here T into AT, that is S equal to UT plus half AT square. This equation is called position time relationship, and it is also known as displacement time relationship. In a third equation, here in the third equation, that is area of a trapezium, that is area of a trapezium, that is equal to the displacement equal to area OABD, and it is also equal to the, because it is a trapezium, so it is equal to 1/2 sum of parallel sides into distance between them. So it is equal to S equal to 1/2. Here sum of the parallel side, these sides OA and BD. So it is written as BD plus OA into distance, that is AC. Distance is AC, and so S equal to 1/2 V plus U into T. From first equation, we know that S equal to 1/2 V plus U into V minus U upon A, since T equal to V minus U upon A. And here 2a 2as equal to v plus u into v minus u. Formula है a plus b to a minus b, that is a square minus b square. So 2as equal to v square minus u square. So this equation explains position velocity relationship, and also explain displacement velocity relationship. Again, repeat equation second and third. In a second, total distance covered by a body is equal to the area under graph in a velocity time, that is equal to the displacement. So it is also known as displacement. The displacement equal to area under graph OABD, and that is area of a rectangle plus area of triangle. Area of a rectangle, that is length into breadth. Area of a triangle, half AC into BC, that is base into perpendicular. And then obtains the formula S equal to UT plus half AT square, and it gives the relation displacement time relationship. In a third equation, the total distance covered by a body in a particular direction, that is called displacement, and equal to area OABT, that is the trapezium. Area of the trapezium 1 by 2 sum of the parallel sides into distance between them. Here the parallel sides OA and BD is the parallel side, and AC is the distance between them, and BD plus OA into AC. Here value put a V plus U into T. Is it clear? And gains, that is 1 by 2 V plus U, V minus U upon A. From equation first, motion first two equations, T equal to V minus U upon A, putting this value, and 2AS equal to V plus U into V minus U. That is the V square minus U square is identity A plus V into A minus V, that is equal to A square minus B square. And this equation 2AS equal to V square minus U square gives relationship between position and velocity. It is also known as a velocity displacement and velocity relationship. Okay, clear? All three equations, and after that numerical problems in next video. Explain the numerical problems. Okay, thank you.